Hey, welcome to another episode of the Contractors Innovation Podcast. We had a few scheduling miscues, and we decided to go ahead with kind of an impromptu discussion tonight on our friend Brian's workplace. Brian Couto, the comedian, Brian asked me whether the FEBTU cell, perhaps with the windmill, would work at the mushroom factory. So I thought, well, geez, that's potentially a good topic to talk to. And so I invited Andrea. Andrea is a mechanical engineer who does a lot of work with the heat exchange and with the FEBTU cell. He was involved, Mohammed, in the day we drew that drawing. I sent you that
Okay.
drawing.
Yeah.
And so we might need to explain the drawing, and I don't see Brian, but
You
Brian
guys
on?
can you see me? If you
Oh yeah, now I
swipe
can.
it to the
Yeah.
left, there you go. If you swipe it to the left, you can see all of our faces at once. That's what I've been navigating this Zoom. You swipe it to the left and you can see all of our faces. So
Yeah.
hello everybody. How you guys doing? Everybody good? There we go.
Good.
Yes,
All
mostly.
right. So the topic for today is we have a farm. They spend a lot of money on electrical. They spend a lot of money on heating and cooling, and they're using the utilities from the city. So they're using electrical, and they're using natural gas to heat and to cool. So it's about say 5,000 square foot uh, I want to say like a big barn, like a 5,000 square foot barn, like a one level concrete floor, you could see, then the roof now it's kind of insulated, but then there's also living quarters in the front, another 2,000 square feet of living quarters. So you have about 7,000 square feet, right? And they also have large fridges, like a big cooler room that they put stuff, coolers. They use a lot of water to wash. They use a lot of water for
Well,
watering, obviously. So, and here's the thing with
explain.
the
Hey, Brian,
farming.
slow down a bit, Brian. Tell us
Yeah,
exact. Give me the story of a mushroom. Like when you say they wash them, like they grow pretty quick, do they not?
yeah, no. So, anyways, they use a lot of water for like washing the factory itself or the farm itself, the barn itself, and they use a lot of
Concrete
water
floors,
also.
concrete
No,
floors.
yeah, so it's concrete floors, yeah. And so the thing with the farming industry is that it's so like you have to be uh innovative to save money because it's not
Yeah.
that you can't sell your mushrooms for more money. The price is here. And now you have to save and be efficient for to make a profit, right? So one of the biggest expenses they have is the electrical and the heating bills, right? So
Right.
what we're trying to figure out today is this system, Martin's system, a good way to heat, cool, and power this 5,000 square foot barn plus 2,000 square foot house all together in one unit. So what we'd like to do is see if it's feasible. Basically, a timeline of how long it takes something like this, and maybe like a kind of a cost, and then and then kind of showing the long run, like how can you save? So is this something that is feasible, right? So I think that would be a cool project for today's podcast if you guys are down.
So Andre might have a few questions, and Andre, take it over if you can nail down exactly what Brian said relative to the size of the building and perhaps the moisture, the element of moisture. But there's water. There must be a well on the property, right, Brian? Like they have no problem with water.
Well, they have a lot of water, and the property is very saturated. I believe they must have their own well water because it doesn't make sense for the city to send water out there. So they must have their
Yeah.
own water system.
Yeah, that's a
Right.
that's a good question, Martin, because I was wondering if it's a mushroom plant that's already using a lot of water, do they have access beyond that to help with the evaporative cooling side of it?
I
If
believe the ground is
if
very
it gets dry.
saturated too. It's a very wet ground as well. So there's a lot of ground. I would say there's a lot of groundwater.
You're not sure though,
That
right? Like what
And
the
there's
technique to put
streams,
one of these. Go ahead.
there's streams and marsh area around as well. You know what I mean? It's not in the city. This is more in the farmland or in the forest, right? So there's a lot of water. There's farmlands, forests, and there's even marsh close to this area, right? It's Acton. Actually, if you want to know, it's in the Acton area. So Acton itself, you kind of know uh, different. Actually, your friend would know, Martin, the older friend. He knows the different soil conditions in different parts of Ontario. But we're talking about Acton area.
Who's my older friend?
Remember, we went on to that luncheon, and you were showing him the Chem Concrete,
Jeez,
and we had a luncheon with the three of us and William.
Oh yeah, you mean Norm?
Correct.
Norm.
See,
Yeah.
I never forget a face.
Yeah, he's 87. Yeah. So he's
And
older.
he has conditions for soils all over Ontario because he has been testing for years, correct?
Well, he's been
Like
drilling for years. He's been putting
correct.
foundations in for years. But in a place like Acton, when you have swampy ground, I guess the key question is we'd have to assume, Andrei, that they have a lot of potable water from a well.
Correct.
If we
I
can always,
Yep.
we can always
Go
sink a
ahead,
drilled
sorry.
shaft. We can always sink a drilled shaft, and we can always buy liners. So this drawing, which we were revisiting from several weeks ago, it shows a windmill, fan powered, and that you would get a lot of
Yeah.
cooling. Like, would you say the mushroom needs to be cooled? Like, they don't want warm in there, right? Do they have air conditioning running?
They have air conditioned heating and they have CO2 in the air as well. So the
So where do they
heat,
get this?
the room, so the rooms where they grow are relatively warm, maybe around 20 degrees or so.
Right.
And then after they're trimmed, they need to be put in the cooler, which is like a fridge. So we're talking around 5 degrees, you know?
The fridge will need power, which the turbine will be able to provide, which is quite good. The fact that the groundwater is quite saturated with water, it kind of reduces my confidence in using just the evaporative portion, because if it's already saturated in water, it's you're not going to get to a point where it's going to want to naturally dry out with the evaporation and diffusion. And so with that type of thing kind of benefits more like California, Oregon. But everything else, this seems really nice. You said 5,000 square feet, and they have a bunch of fridges everywhere. So it's kind of industrial.
They have one big fridge. They have one big cooling system right now, but they also, but it does take a lot of cooling. It's a big fridge. It's a big cooling room.
How cold does it get in that space? I wonder if just this part itself, the heat pump working in cooling mode would be enough to cool it to the levels you need, or if not, that's okay. We can use the turbine to power a separate fridge and do this. Do you know how cold it gets?
I believe when I'm in there, it's not below zero. I would say around 5 degrees. 5 to 10.
Yeah, that's probably
I mean?
more than what a heat pump would do comfortably. Maybe not, but worst case, we could just. So the thing is, what you see for the folks viewing this podcast is right now that's a shaft in the ground. Above that, you would have a vertical kind of like a wind turbine spinning, where the axis is pointing to the sky, basically. And depending on, I don't know how it is in Acton in terms of, I guess that's on the escarpment, right? That's not below the mountain? Sorry?
No, it's on the escarpment. Yeah, so it's higher up.
On top?
Yes.
Okay.
There's a lot of trees around. But there's a lot of trees, but it's a lot of flat land. So the wind, there's enough wind movement, right?
That would be great, yeah. And then that itself, that turbine spinning and the generator would help power whatever setup we have. So that would be a lovely project if we could take that on and help them grow their mushrooms, whatever kind of
If we
mushrooms they
could
are.
break that down, like because you guys are the experts here, so as a person who does not understand the technical language, I would really like to have the idea there. If you guys could break that down from the step by step, what happens from step one, and then what happens, and then what are the end results that we can expect as a person or as a developer who installed that in their.
Yeah, so do you think we'd probably only need one windmill, Andrea, and one large, whether it's 30 ton or not? 30 ton might be high, but if you're going to drill one hole, you see that plate in just below the top of the gravel? See, there's a plate there.
This one?
Yeah, it's a 1-inch plate by.
It's lower.
Yeah, like that.
Yeah.
That right, yeah, right there. So that plate, that probably should be deeper in the gravel, Andriy, wouldn't you think? Like one of the things we need to do is make sure that the windmill pipe is surrounded by gravel. That plate should be drawn lower. We can address that later, but I'm just pointing out to Andrea that to brace that windmill pipe, you have to have a lot of clear gravel around it so it holds the pipe cock stiff, you know. And then
I think you're right, and
yeah,
Is
you can
that
drill quite cheaply. Sorry, Martin, your technique allows you to drill quite cheaply, so
yes,
we can
right.
go deep.
Yeah,
So,
like
somebody started talking. Sorry about that.
Can you
so
show
is
the
one-
other? Can you show the other drawing, Mohammed? Can you put the other drawing on? The circle. There's another
Sure.
drawing. Yeah. That drawing there. So there's obviously a ton of gravel holding that larger liner, but you need a lot of gravel holding that smaller windmill pipe. So that's why I think that end plate on that windmill pipe should be, 8 feet deeper, so that you have gravel holding the windmill cock stiff.
And the windmill itself, how much power is it going to generate?
Well, I think in this case, Andrea, you'd almost think that the 5 kilowatt would be enough, but if you use the different motor sizes, you can use a 5 or 10 kilowatt. That's the two sizes that we thought would be commercially usable. Like 10 kilowatts, a lot of power. Keep in mind that, that power can go to industrial batteries. And when it's windy, the batteries are almost always full. Like at my place, just from the solar, my batteries are full. So there's this aspect, Brian, of batteries, that you can kind of deal with batteries, which means you probably only need 5 kilowatt. Like above the roof of that mushroom building, would you say it's windy there? Windy enough?
Yeah, I would say
Yeah.
it's windy because the tree line is not they're not very tall trees. The trees are 2 stories high, worst case, you know what I mean? And then it's a lot of open field all around this barn. So the wind will pick up well, there's a lot of open field.
So you could put this drilled shaft somewhere where the windmill would catch wind, and you could put it so that it's. I think one shaft would be enough, Andrea. What do you think? Oh, here's a. Is this Andrea's drawing? Yeah. Andre,
Just to
go ahead.
I think I emailed this to you guys mainly so that Mohammed, you could see kind of from a more approachable point of view what this is. So this is kind of what it looks like on top of the turbine. You could have I have a 10 kilowatt written there, which, by the way, Martin, if you have a 10 kilowatt power generation, if you want to completely offset your heat pump for the heating and cooling, you could do up to about 10 ton. In our case, maybe 15, because it's off by like kilowatt versus ton is off by like 3.4, and we're hitting COPs of 5 with the heat pumps that we're using. So it's kind of a safe. If the same kilowatt number is the same tonnage that you would get for the heat cool. It's like 3 times more, basically heat cool, because when you're dealing with heat pumps, you're just moving heat. You're not generating it from like a furnace or resistance heating where it's 100% efficiency, but you're basically creating it. You're converting that electrical into heat. But here with heat pumps and air conditioners, but heat pumps is like a reverse air conditioner. We're just moving heat, so you could get 300% efficiency.
Wouldn't it be a water furnace though?
Well, that's one company that provides it. You could have there's others that do the same thing, but water furnace is a good one. Yeah.
So
water furnace is the name of a brand. You mean it's the name of a brand, Andriy? Is that what you're saying?
Water furnace is a brand of.
I thought water furnace was the nature of the beast. In other words,
yeah, it's like Kleenex,
we're circulating water with a water furnace. We're not circulating glycol. I always think of a heat pump.
Or like a chemical furnace. We're not, it's a brilliant name for it. It's like a Chesterfield or a Kleenex or like they've dominated the market. Yeah,
and this system doesn't need glycol. It doesn't need any of that stuff. It all works on water, which is safer, more natural. Correct?
Right.
Yeah.
So
particularly when you have a well water, you've got endless supply. Like Andriy will tell you that there's given a certain rating, you need to use up a lot of water in that gravel.
Yeah, so, and I know there is a lot of water. Does it have to be clean water or anything, or can it be like any gray water and stuff to use it to cool it?
Generally, you want it to be potable. Like I don't
ideally,
know, gray water.
Ideally, but so they use a lot of water to wash down and stuff. There's tons of water going out all the time. I was just thinking
water would be potable. So in other words, it sounds like they have lots of water because their well is very productive, right?
Yeah,
like they have. Go ahead.
Yeah, they have a lot of water. It's not so much the pressure, but they have a lot of water. We can only have like one hose going at a time, like an industrial hose, not a fire hose, but an industrial garden hose, right? Like an industrial. So if you have more than one hose, just the way it's set up, but it does there's water running all over that place. They have water to run the beds. They have 6 rooms. So that's 6 rooms that need water for the mushrooms they use to wash. There's a lot of to wash the grounds, not the mushrooms themselves, but to wash the ground. So a lot of water does get used when they're operating.
Okay. Well, the water here will mostly cycle if we're not doing the evaporative cooling, but it's good to know that they're not depleted in that sense. And if we ever have like dry days, we can use it for evaporative.
And if you're using a 10 kilowatt turbine to generate power, you can also use that power to offset any other electrical that you need in the house, like for extra cooling or extra heating or lights or the stove. They have kitchens. Obviously, there's a house hooked up to it, right?
So is the house where the people live? Do the people live there?
Correct. The owners of the farmers, they live there, right? So they have their dwelling there. So it's because basically mushrooms grow 24 hours a day, right? So you can, and if you have 6 rooms going, you have to pick mushrooms within a few hours of when they're ready, or else they'll start to keep growing, and then they start to turn into a less quality mushroom, right?
So how does a mushroom get seeded? Like I can't imagine if you started, it's just always growing spores in there, like it's.
Yeah. So every 14 days, the mushroom goes through the whole cycle is a 2-week cycle, right? So basically, from the time they fill up the beds with the peat moss. Yeah, the soil, the peat moss, the seed, you know what I mean? All that stuff. They put lime in there. They put all they make a whole concoction. It's got a mix for a day, and then they put it on. So from the point of planting everything to the point of cleaning it all out is about 2 weeks. So you'll put in all that. You'll put in your mix, your dirt and everything, your fertilizer. You'll get it all set up, and then within the first week or so, you're starting to pick. You know what I mean? You're starting to pick the bigger ones because they start to clump, and you got to kind of. It's almost like forestry, responsible forestry, when you start picking the bigger mushrooms out, kind of thing. So you kind of thin out the mushrooms. So you're doing that the first time, and then the second time, and then the third time. And then sometimes they'll ruffle everything up, and then the seeds that didn't catch before will catch again. So you can probably get, 3 growths, and then ruffle it another 2 or 3, depending on how it goes. But the seeds itself are like little tiny little seeds. Like, I don't know, if mustard seed.
So they actually plant seeds to make mushrooms?
Well, it's kind of mixed in. They get the mix and they mix it all up, and that's why it's mixing for a day. And they mix it in a big concrete truck. Yeah.
Really?
So like a concrete truck mixes it all up, and then it goes on a conveyor and then gets made. It's a really interesting process, and it's all done indoors so that you can grow 365 days a year. It's quite an interesting process.
We'll power the conveyor belts.
Yeah, and that's what I mean. Like they use a lot of electricity for a lot of the machinery that's used there. All the conveyors are all electrical, and it's the big, the ones you lock in. So it's like the 250 or whatever. So they do use up a lot of electricity when they're operating. The heating and the cooling, that system that you have, the building has already existed. So do you put the windmill and everything in the center of the building so that the heating and cooling is closer to everything, or does it matter?
I don't think it matters if you've got fan power and circulation, right? So in other words, there would probably be a structure on the perimeter that would be framed on its own with the windmill above it, right? So
Yeah.
you would probably locate it strategically to be useful to the water circulation and to the power, right?
And right now they have a furnace. They have a furnace that is natural gas. So do we convert it, or do you have a whole new system? How does that work?
Well, the furnace is generating heat, correct?
Correct. Heat, and they have a cooling system as well, and everything runs off of natural gas. So they must have air conditioning units maybe to cool the coolers. But it's all running on electrical. Yeah,
Like
go
a
ahead.
fridge itself.
Yeah, it's like
if it's small, like yeah.
Fridge. Yeah, it's a walk-in fridge. So so they use natural gas and they use electricity for heating, cooling, and to power their lights and the machinery and everything else inside.
That's probably what we're going to have to deal with 90% of the cases or more, where they use like a furnace or electric resistance heating for the heating, and then for the cooling they use an air conditioner, whereas this type of solution would cover both things, unless it's very specialized super cold. Sorry,
I would think the air conditioner would work well, would it not, Andrea? I would think so. The evaporative cooling.
Well,
it's going to be chilly.
Yeah, I mean, it does the job. It does the cooling job as well. It's heating and cooling, so it does the AC job and it does the furnace job.
Just as long as you got a thermos, it's driven by a adjustable thermostat, I would think.
Yeah, for
now,
sure.
once this is built, what's the monthly cost to run this versus the electrical and is there any kind of cost once this is set up?
Well,
mainly
I would
capital.
say the idea would be to get off grid. So you're looking at a net savings, Andrea. Like basically the idea is it's a net saving. We call it the ideal off grid device. Because once you have a windmill that generates power, the sky's the limit. The geothermal generates cooling and heat. So you have kind of an integrated system. and the other utility bills become savings. Because when you're
you get
working with, go ahead.
I was gonna say 5 to 10 year payback period to add to your point, Martin.
Yeah, depending on what their costs are right now. Because if it's already, because I'm sure there's inefficiencies too, like the building isn't 100% insulated and stuff. It's all block. You know what I mean? Like they're still working on the building itself to make it better. But just on the heating and the cooling, I could just imagine what the bill is. Like I'll get a for sure number for our next podcast together. But I'm sure because I remember back in the day, my parents heating a 2,000 square foot home and paying $350 for heat that month, right?
Yeah.
And that's on 2,000 square feet. And that was, 20 years ago. So I could just imagine what that heating bill must be. And what does a system like this cost, roughly, ballpark, for us to build? If we were going to build, and is there a payment strategy for people who don't have all that money up front?
Brian, you're a hard guy to keep up with. You have all the right questions, but it's not necessarily true that we have quick answers for those questions. I mean, the benefit of what we're dealing with our geothermal is it's structurally able to support a windmill. So when you connect those two, it's unique in the sense that other people's geothermal are horizontal loops or mud drilled holes in soil, and they don't have any structure to them relative to supporting a windmill. That's why I got the second patent. The FEGEO wind is a supported windmill that uses the evaporative cooling stone to find bracing. And also, there'd probably be struts on that. Like the drawing doesn't necessarily show it, but that pipe can be braced off with 4x4 structurally. So you'd end up with kind of a solid X connection at grade, and then it would go down, the windmill would go down into that gravel, where I say the plate should be extended into that gravel on that drawing. But it's a good drawing. Andriy and I did with the one where, well, not this one, but the first one we looked at, we had the fan powered and it's a 24-inch HSS 3/8 pipe. So that 24-inch HSS 3/8 pipe, Brian, is a closed system that circulates water. So that becomes all you have to do is open a stop valve and it would leak it into the gravel. And using the fan power, or even without the fan power, you're going to see a real response to a thermostat with this system.
Cool. That's awesome. Yeah, guys, just before you got to bounce.
Drop off. Yeah. Sorry.
Yeah, just before you got to go.
2-year-old.
What do you got, a minute?
No, I got a minute. Yeah. Sorry about that, guys. It's been a little.
No problem. How long does it take to do one of these? Like,
hey,
to build
Andriy,
something?
I got my letter here. This is.
Thank you, Martin.
Yeah, it's right here.
Yes.
So
I love that.
Good.
And how long does it take to set something up like this, start to finish, roughly?
I would think it'd probably be a 1 to 2 month job to convert
Yeah, to convert, but I think to actually drop it in, it's like a couple of days with Martin's experience.
Yeah.
And technology. But the machine shopping part is the probably longest. And then
but to actually build, to get the structure in, to get the windmill up and running, if you touch 2 wires, it'll be generating power. That's roughly a couple of days.
No, it's, you've got you pre-assemble the windmill and then you lift it on and like within a day, you probably have it braced off. So
so you can have this thing built in less than a week if you really wanted to.
Yeah. You got to coordinate with the trades and the existing business, but correct. You got to pick the right location.
But I mean, if it was full steam ahead, nothing stopping you, within a week, you can have this thing started to finish and you already have your system. And then you just got to hook it up to whatever right? Or converts whatever, but you can have the system up and going in about a week.
Yeah, you probably have a couple weeks to get the batteries hooked up, and you know, like you're basically off grid, so you need to have power, but you also need to take the power from the batteries and use it, right? So you end up having to have industrial batteries for an off grid situation.
No, that's awesome. Thank you very much. I think this might be something we should look into for the farm for sure, 100%. So yeah, thanks a lot.
We were hoping to have Chem Concrete on, but those guys they're camera shy, put it that way. But the I had to react, and I didn't really want to lose the slot with everybody. So we should be able to. I don't know if Brian's been funny enough tonight, but you know, we should be able to do the 5 shorts.
Yeah.
Yeah, 100%. And you know what? We can even let Andreas. We can let Andreas go, and then with the 4 of us can mess around for 5 more minutes. We could even do that. We can let the man go.
Well, you got to go.
We should have recorded We should have recorded the start, Martin, when we were setting up. There was some jokes there, but yeah.
There was so much.
Oh, you always record without me. Don't worry about waiting for me to record. Brian, press record. Whatever.
Thank you so much for having me.
Or Mohammed.
You guys are awesome.
Yep. Have a good one.
Thanks a lot, Andreas.
Thanks for everything, guys.
Andrew's having another kid.
Cheers. No TV in that house. Let's go.
Yeah, man. Yeah.
All right, Andreas.
I'll have to ask you guys for advice.
Pull out.
Have a good one.
One way, I guess. It was intentional. It was intentional.
It was. That's good. Hey, it's a blessing. It's a blessing. If he
so your advice for population control is pull out, right?
Yeah.
That's a good one. Well, that'll make
maybe
after
the 3rd one or the 4th.
Yeah, after the 3rd one.
Take care, gentlemen.
That's all right, brother.
All right. Cheers, guys. Thanks.
So, Brian, horse around like you did at the start if you want to get help Mom get a few more shorts. See, I thought that Brian might have a career as a sales guy. You know, if we could get him a little bit like he's worked around foundations, so he's got the energy to come in and get people to like him. I think a lot of sales is about having be likable. Do you agree, Mohammed?
That's 90%. That's 90% of sales. Yeah.
Yeah.
That's crazy because car salesmen, everyone hates them.
Yeah, but they buy the fucking car.
Yeah. Absolutely.
We'll hate them after they buy the car. They hate them.
Yeah. I only say that because my brother's a car salesman.
How much does the guy make?
Everybody hates your brother. Everybody hates your brother because he's black, not because he's a car salesman.
They pay big commissions as car salesmen.
They get big... Yeah.
I think so. I think it's commission, like depending on which dealership you work at. 100%. So yeah,
it's commission 100%. You know what's funny? So that system, the windmill and everything, it's about $20,000 roughly to do that system.
With batteries, you'd have to be fair.
But batteries
it's going to be at least $50,000 to put that together.
Once you get batteries and everything else,
even the windmill, Brian, from Mateo, one of those windmills is worth $19,000 US.
Yeah. So just the windmill is almost 20,000.
Yeah. So you can see how it could be. And for a factory to get rid of a utility bill, 75,000 is not a problem in terms.
Well, and that's what I'm thinking. I think their utility bills is like over 1,000, maybe 2,000 a month. I would say easy. I would say.
Maybe ask him that.
Yeah, I'll ask and see what's going on. If you're spending 2,000 a month, that's 25,000 a year that you're spending just on utilities. So in 4 or 5 years, you would pay it off if it costs $100,000 with everything, changing things over. You know what I mean?
Yeah, and that is what one of the slides was saying. Your payoff period is like 5 years. So and then for the rest of the time, you're good because then you don't have those utility bills anymore.
Yeah.
Yeah, right there.
Yeah, there we go. Yeah, and then I'm sure you could probably get some kind of a grant or something. Isn't that some available to get this project on the go? What do you think, Martin? Is there any grants?
I don't think the paperwork is worth the effort. You could call it feed-in tariff. You could call, mainly what you need to do is justify it to a bank. So the idea would be, hey, we've got a quote here, and we'd like to get a loan, and then
Yeah,
take the bank's money, right? And
yeah. I think Martin. I think maybe I'll talk to them this week if they're interested. Maybe we should write up a quote.
well,
And
certainly, I'd have to go see the site before I'd ever do a quote.
of course,
But
100%.
it's probably just try to find out how much the utility bills are.
Yeah,
And whether they'd be interested in a free energy device. These drawings here, Brian, you might want to have a copy of those drawings. Say, here's
Yeah.
something that, I'm thinking about getting into this next year with this guy. And I was talking about your factory here.
Because I just
So,
think
yeah.
I already mentioned to her. I already mentioned it to the owners. So she was like, "Yeah, on a Saturday is the best time to come and take a look. So if you're interested in coming by, I'll talk to them. But if you're interested in coming by, it would be a Saturday that's best to come. So
Yeah.
maybe figure out a day that works and we take a look at that sitch, because I think it's a good investment for them, because I know that the furnaces and everything are old. I'm sure it's going to need replacing soon. So instead of spending money on replacing furnaces, get a whole new system that takes you off grid.
Yeah. You think that they're
Right.
going to, yeah, exactly.
Yeah, because a new furnace is going to be 10 or 20 grand as it is to to replace the furnace, right? So this, you can get the heating, the cooling, and electricity, and you're totally off grid. Within 3 or 4 years, you have it paid off. Because I
Right.
think they're spending more than $2,000 a month
Mhm.
for what I see. Definitely. You got coolers all day. You got coolers going. You got heaters going. You got electricity. You got water. It's crazy. So there's all kinds of stuff going. So I think it would be a good system, actually, and I think this system would be really good for a lot of the bigger builds that you see. A lot of people are buying property that doesn't have electricity, like here in Canada. So we would have to pay $50,000 to get the power line from the road to the house. The city charges $30,000 to $50,000 to dig a trench, to send, to put a post at your property line, and then you still have to get it from there. But it costs $30,000 to $50,000 to put a post at your property line. So
Right. So
that's almost the price of the windmill and the whole. You know what I mean?
yeah.
Right.
Yeah.
So if this is something that, because I know a lot of people that build even their own house, like it's one of the things that we save up money and we want to build our own house. So we buy a piece of land, out in the country or something, and it's away from everybody. It used to be a forest, and then we cut out some trees. We start building a house. There's no power. There's no electricity. There's no water. There's no heat. We got to do everything ourselves. So something like this is almost the same price as getting it to the property line, if it's even possible, right? Because a lot of times there is no power. Like we have a lot of forest out here in Ontario. Like we have tons of forest, so there's not power lines everywhere. So this would be a great concept. Even to build a cottage, even if they're doing a cottage, this works, right?
Yeah, it's certainly more cost effective than solar. I mean, if you have solar, you still need the batteries, but if you have a windmill, it's called a wild windmill. So it catches the wind from all different directions, and it doesn't kill birds, which is good.
And do you need like permits or approvals for
Yeah,
this?
it's a good point you brought up. I was talking to my permit guy today, Jed. I do some engineering, Brian, with the fellow who drew these drawings,
Correct.
and he always does like he does like houses that are on pads, like small
Yeah.
houses for modular home
No
guys.
basement. Yeah, no basement.
Yeah,
So
no,
slap on grade.
which is the way to do it, really. So but he's a permit expert. So in other words, I stamp the stuff, but he basically knows the building code inside out. So I was talking to him today, actually, and I said, "Can you do permits for these off-grid projects?" And he says, "I can do permits for anything like that." In other words, he'd interact with the town, and he's got friends at the town, and he'd say,
Okay.
"What do you need?" So then he would basically be able to draw it, right? So
Yeah,
he's a CAD guy.
parameter. Yeah.
Yeah, like the windmill, we could almost do an architectural drawing of the windmill, but the actual drawings, I have the actual drawings of the Fragoni windmill, and that's the 19,000 US for 10 kilowatt or whatever. That's a refined design. We call it FE GeoWind 2.0. So I had one up for the better part of a year, but it had a little rattle in it, and it was built in a rush. So now we've done the whole engineering again, and we have options on 5 and 10 kilowatt, which I think is the right sizing. And then with the geothermal, I think you're wise to go big or stay home. In other words, fan powered and try to get 20, 30 ton heat cool by using water. It's a very efficient thing. It's no danger to the environment. Like unlike glycol, you can't leak glycol around it. A geothermal typically is 300 feet deep, has a return on energy of 2.5. So our return on energy is 5. COP.
It's double. And you only got to dig down 20 feet?
Yeah, drill down probably. It's going to be drill, right?
Drill down 20 feet, sorry.
Yeah. So whether it's Norm's machine or it's not good to hit water when you're drilling, but with the casing systems they have, Brian, you can certainly deal with it, right? You can put the casing in, get it down, get the stone in, and then because a lot of my casing stays. Like if I have that outer casing, I leave it in. So if you could screw it in, like the old ways we used to screw the casing in. So there's different casing systems. Sometimes you'd have to use a luffer casing, which bolts together just to get the other casing in, and then you'd pull the luffer out. So a lot of the industry uses luffer casing, bolted casing. But then what I do is I leave the casing behind, like the 24-inch casing for the windmill. All that casing is bought without consideration of reuse. It's not like a bolted casing that you take to every job. The problem is you're mobilizing for one job, like in terms of your job there. But typically, you can imagine
the cost is the setup and stuff as well, right? If you're only doing one hole versus if you're doing 10 holes, right?
Right.
Your cost per hole is cheaper.
Yeah, conceivably, if you had 100,000 square foot warehouse, you might have 10 windmills, 10 holes, and 2 weeks worth of work.
Yes.
In order, and then you'd have a lot of industrial battery and different things like that. But I think I've proved it enough to know it works. And the people that like Andriy is a heat exchange expert. He can't believe how he thinks it's an amazing.
And how easy it is to do the repair or like to replace any components? Is it easier or do you?
None of the components below grade need to be replaced. So, if you're typically you'd have a building covering it. So, you might do a lean-to, Brian, on one side of the building, frame it up, and then you'd have a water furnace. So the water furnace would be in close proximity to the hole. Like my water furnace was probably 10 feet away from my test hole. And so I think I used 7-ton water furnaces. And when I ran that with the evaporative cooling, the duct froze. Like the duct actually gets so cold that it looks like, oh, you'd have to be careful touching it because you think, well, when my hands stick to it. That's how powerful evaporative cooling is.
Wow. I think Brian might have lost Wi-Fi or something like that. Seems like he disconnected.
So, like, Martin, I have one question for the viewers as well. Who would be the ideal customer for this? A condo developer, commercial buildings, off-grid homes. Who do you think would be the best?
I would think anything off-grid. I mean, the idea is it's off-grid, and a lot of stuff can be off-grid. So if you don't pay, like Brian spoke briefly about having to get a service, having to get a pole, having to get a town to agree to a subdivision. But if you build off-grid, it's a lot more palatable for the permit process because they don't have to plan the hydro load relative to the road.
Okay. So can it also scale for large commercial projects?
Yes, I would say it's really a case of, where this device, so we believe it's got a lot of potential, is in AI. Because AI needs a lot of cooling. So if you have that for AI, you've got an unbelievable air conditioner. Like imagine the cost of air conditioning those computer rooms.
Yeah, the data centers.
With evaporative cooling.
Yeah.
It's 850 BTUs per pound evaporated. It's one of the most powerful forms of in nature. So by me switching from glycol to water was kind of the game changer in terms of its potential for the future.
Mm-hmm.
Okay.
It has tremendous potential for the future in terms of,
as we're talking about like AI, is there any like smart system or any software included in it to optimize it, or it's all?
Well, not, you really have, if you're in a computer room, there's sort of a net load, and engineers can calculate the amount of cooling they need to keep the temperature of the computer room at 65 degrees, let's say.
Mm-hmm.
That's a relatively straightforward calculation. So if they have a certain formula for calculating cooling load, then we can easily meet that cooling load through evaporative cooling with maybe one hole. Right? And the benefit is if we have a windmill, we've got the best of both worlds because we have the second patent allows us to generate our own electricity.
Baby, I need to know.